Hi guys, welcome to another video. The topic for today is inequalities. Okay, this is in line with the topic we did yesterday or the previous time, that was absolute values. You will see most of the times absolute values and or modulus and inequalities, the questions are mixed together. So it makes sense that we study both of them back to back. Okay, now coming to inequalities, what are these? So instead of an equal to sign, you have an inequality sign. So that can be greater than, equal to, less than, equal to, not equal to. All these are various inequality signs. Okay, but again, you don't have to worry. We treat them or we solve them in a very simple manner. The way you solve any normal linear equation or quadratic equation, right? You solve inequalities the same way. There is just a little twist, okay, that we'll learn and see what is different from your normal equations. Okay, let's start with an example first. Okay, say we have an equation 2x plus 5 is equal to 70. Now I know, I'm assuming all of you know how to solve this. 5 goes there, 2x becomes 17 minus 5, 2x becomes 12, x becomes 6, right? This is how we solve linear equation. Okay, now looking at inequality, we solve the inequality also the same way. Okay. Alright, nothing changes. Say we have 2x plus 5 greater than 70. Same thing will happen, same steps will be repeated. 5 will go there, 2x becomes greater than 17 minus 5, 2x becomes greater than 12. Now 2 goes there, x greater than 6. So if you see, the steps for solving inequality and your normal equation, they are almost the same. Okay, not almost, they're exactly the same. The sign changes. See, we had equal to sign here and we have a greater than sign here. So the sign changes. Okay. So then question comes that if everything is same, then why are we learning this separately? Or is there anything that is different? So yes, there is one point that is different. Now before we learn that, let's learn a basic concept so that we can understand what is the difference. See, when we have positive values, okay, if we have positive values, okay, then the greater the number, the greater the value. Okay, the higher the number, the higher the value. What does that mean? That if say x is 10, y is 5, so the greater the absolute value, the greater the number. But on the contrary, if x and y are negative, okay, if x and y are negative, and again the value of x is 10, value of y is minus 5. Now what happens here? We don't say minus 10 is greater than minus 5. What do we say? We say minus 5 is greater than minus 10. The point being, for negative numbers, the relationship is reversed. The smaller the value, okay, value in the sense the absolute value, only the numeric value. The smaller the numeric value, the greater the number. Okay, or in other words, the greater the numeric value, the smaller the number. So the relationship of positive versus negative is reversed. Okay, that is why when we solve negative inequalities or whenever we have negative numbers, we have to change the relationship. What do I mean by this? Say the same question, but we had minus 2x plus 5 greater than 70. Okay, same question as before, but now we have minus 2x. What happens? Minus 2x greater than 17 minus 5, minus 2x greater than 12. Now we will say send the 2 there. So I will have minus x greater than 6. Okay, I have minus x greater than 6. Now when I send this negative sign, because I want x, okay, I want x. So when I send this negative sign, I have to remember that for negative numbers, the relationship changes. For negative numbers, the relationship changes. Hence, my sign also changes. Hence, my sign also changes. Let me explain this again. Okay, let me explain this again. What we are trying to do here is that whenever we multiply or divide by a negative number, whenever we multiply or divide by a negative number, the inequality sign changes. Okay, whenever you will multiply or divide by a negative number, the inequality sign will change. Similar question if we have to do say slightly faster. Say we have minus 3x minus 8 greater than 7. You have minus 3x, minus 8 goes there. Now remember, I am just shifting. I am not multiplying, not dividing. I have just shifted this 8 from left hand side to right hand side. So don't change the sign right now. I get minus 3x greater than 15. Now I am going to cross multiply this minus 3. Now I am going to cross multiply this minus 3, or you can also think as I am dividing both sides by minus 3. Okay, you can also think of it as I am dividing both sides by minus 3. So because I am dividing, now the inequality sign changes. Now the inequality sign changes. Okay, so whenever you multiply or divide by a negative number, only then the inequality sign will change. Okay, I hope you understand the basic concept of inequality. Now had this been a different sign, okay, had this been a different sign, say instead of greater than, had this been less than equal to minus 3x, or let's take a different, okay, minus 3x minus 8 less than equal to 7. Minus 3x, again the 8 goes there, less than equal to 15. Minus 3 goes there, 15 by minus 3, the sign changes. The sign changes. We get x greater than equal to minus 5. Okay, we get x is greater than equal to minus 5. The point being, whenever you multiply or divide by a negative number, then you have to change the inequality sign. Why does that happen? Because for negative numbers, the relationship is reversed. The smaller the absolute value, the greater the number. Okay? If you understand that, then let's move on to multiple inequalities. Okay, if you understand that concept, then let's learn the concept of multiple inequalities. These are just multiple equations that you are solving at once. Say for example, say we have the same equation, minus 3x plus 8 is greater than minus 1 and is less than 70. There is an equation minus 3x plus 8 which is greater than minus 1 and less than 70. Now there are two things that you can do to solve this. One, separate them into two equations. You can do 17 is greater than minus 3x plus 8, or minus 3x plus 8 is greater than minus 1. Solve both of them separately and get the answer. If we solve this, 8 goes there, 9 is greater than minus 3x. Again, cross multiplying the minus 3, minus 3 less than x. Okay, minus 3 less than x. Sign has changed. Similarly, if I look here, minus 3x greater than minus 9. Now, if you are tempted to cancel the minus and minus, remember that is similar to multiplying by minus 1 or dividing by minus 1. So don't just cancel this minus and minus. Okay, don't do that. That is wrong. Okay, instead you will have to, if you're cancelling the minus and minus also, you will have to change the sign. Okay, if you're cancelling this minus and minus, then you will have to change the sign, because cancelling minus and minus on both sides is same as multiplying or dividing by -1. Okay, I hope you understand that. A simple thing you can do is just cross multiply the -3. So sign changes, -9 over -3. You get x less than 3. Now that you have two answers, we combine the two and we get x is less than 3 and greater than -3. So if you have multiple inequalities, no problem, break it into two parts and solve both the parts. Okay. Now, for little lazy people such as me, what we do is, we don't want to write so much, we don't want to solve so much. So what we can do is 17 minus 3x plus 8 minus 1. We solve all of it at once. Okay, we solve all of it at once. Step number 1, I don't want this 8, so I subtract 8 each side. Okay, so I subtract 8 from all of these. So I get 17 minus 8 minus 3x plus 8 minus 8 minus 1 minus 8. If I solve that, that is 9 minus 3x minus 9. Okay. Now that I have solved that, again I don't want -3, so divide by -3. Okay. Divide every term by -3. If I am dividing, inequality sign should change. So 9 by -3, sign changes, minus 3x by -3, sign changes, minus 9 by -3. If I solve this, minus 3x, x is between -3 and +3. X is between -3 and +3. So even if you have multiple inequalities, the point I am trying to make is solve them normally. There is nothing different here. Just solve it normally. You can either break it into two parts and solve each part separately and then combine to get the answer, or else you can solve it simultaneously. Alright, so now we know how constants work, how shifting of terms, constant terms work. If it is a plus, you can shift there minus, plus minus, no change of sign. But if you multiply or divide by a negative number, you have to change the sign. Okay. Now, say we have variables. Okay. Say we have variables. Say the question is x by y is greater than 1. Now we are usually tempted to cross multiply the y. Okay, we are usually tempted to cross multiply this y and write x greater than y. But don't do this. Okay, this is wrong. Do not do this. This is wrong. Why? Because we don't know the sign of y. We do not know whether y is positive or y is negative. Since I don't know whether y is positive or negative, when I cross multiply, what do I keep my sign as? Do I keep it the same, that is greater than, or do I change it? So whenever it comes to variables, we need to know the sign of the variable. Need to know the sign of variable. Once we know the sign, then we can cross multiply or divide. For example, here for this question, you will have to make two cases. If y is positive, if y is negative. Now, if y is positive, you can cross multiply and keep the same sign, because whenever you cross multiply positive numbers, sign remains the same. When you have y as negative, one common mistake that people make, they try to put a negative sign here. That when you read the question that y is negative, you try to put a negative sign here. Don't do that. Don't do that. Okay, y is negative, we know that, but y is y. Don't put a negative sign out in front of it. let it be y only. Okay, now when you cross multiply, treat it as negative. Okay, treat it as negative. So x, you cross multiply y, because y is negative, I know the sign changes. Because y is negative, the sign changes. Alright, so the point I am trying to make is, if you have variables, no problem, you can solve them as well. If you are just shifting variable from left to right, no problem at all, you can do that. But if you're cross multiplying variable, you need to know the sign of the variable. Let's look at some examples. Say the question is xy is greater than y. Okay, say the question is xy is greater than y. Right. Now don't rush and cancel the two y's. Do not rush and cancel the two y's. Why? Because that is same as division. Again, you do not know the sign of y. So don't rush and cancel these y's. Okay, instead you will have to make two cases. Y positive, y negative. If y is positive, now you cancel, no problem. Okay, if y is positive, let me just write it again. Say xy is greater than y. Now you can cancel the two y's. Because y is positive, sign will remain the same. Okay, sign will remain the same. Similarly, if y is negative, you want to cancel, basically you want to divide by y on both sides, you can, but the sign will change. You can, but the sign will change. Okay, you are cross cancelling y and y, but this sign will change because you are cancelling a negative number on both sides. You are cancelling a negative variable on both sides. Okay, so remember, for variables also, they behave like constants do. If you are just shifting variable from one side to the other, say we have minus 3x plus 8 greater than minus 7. I send the 3x there. Instead of sending the 8, I send the 3x there. I will get 8 greater than minus 7 plus 3x. Minus 7 comes here. 15 greater than 3x. Divide by 3. X less than 5. So if you are just shifting the variable from left to right or right to left, it behaves like normal equation. But instead, if you are dividing by variable or cancelling variable or cross multiplying variable, you can only do that if you know the sign of the variable. Okay, you can only do that if you know the sign of the variable. If the variable is positive, keep the same sign and do whatever you want. If the variable is negative, cross multiply or divide, change the sign. Okay, I hope you understand how variables will work in inequalities. If we do, then let's move ahead to quadratic equations or quadratic inequalities. So till now we saw how constants work. So your basic algebraic linear equation, how they work, how variables work. So that covers most of your linear inequalities. Now question comes, what if I have higher order inequalities? What if I have quadratic inequality? Alright, let's see how that works. So a quadratic inequality, let's take an example, is x square minus 5x minus 6 greater than 0. Okay, we have a quadratic inequality, x square minus 5x minus 6 greater than 0. Now I'm assuming all of you know, okay, how to break this down. Alright, if you want, take 2 seconds, take 10 seconds rather, solve it, find the value of x. Remember, don't break it as 2 and 3 because product of minus 2 and minus 3 is plus 6, but we have minus 6 here. So break it as minus 6 and plus 1. Right, you get x minus 6, x plus 1 greater than 0. Okay, this is your normal quadratic equation. This is how we solve it, right, to get the roots. Now if I just solve and find the roots, see, it's greater than 0, yes. Had it been equal to 0, I would have said the roots are 6 and minus 1. Had it been equal to 0, I would have equated each of these terms to 0. Now, when it comes to inequality, don't make or don't repeat the same step. Okay, from here we can't go to that, oh, x minus 6 is greater than 0 and x plus 1 is greater than 0. Okay, this is wrong. Okay, don't do that. Keep it as it is. Instead, find the roots. Okay, keep it as it is, but do find the roots. All right. Now, okay, so we don't do that, we can't do that. So then what do we do? How do we solve? So there are two ways to think about it. Okay, right now that you have solved this much, see, there are two ways to think about it. A traditional method, which is slightly complicated. Instead, I'll teach you one trick. Okay, so let's just quickly look at the traditional method first, and then we'll go to the trick directly. Alright, think product of two terms. Okay, product of these two terms is positive. So think, how can product of two terms be positive? Either both are positive or both are negative. Think about it. How can product of two terms be positive? Either both of them are positive, positive into positive gives you positive, or both are negative, negative into negative then gives you negative, right? So if both are positive, x minus 6, x plus 1, right? If I combine, I know x is greater than 6 and x is greater than minus 1. The common answer here is x is greater than 6. Okay, the common answer here is x is greater than 6. Similarly, if both are negative, x minus 6 less than 0, x plus 1 less than 0, x less than 6, x less than minus 1. Again, if I look at the common answer, x is less than minus 1. Okay, so we get two answers. One, because both are positive, so positive into positive should give me positive. Similarly, one, both negative, because negative into negative also gives me positive. Now if you want, we can verify some values. Say x is greater than 6. So let's take a number, say 8. If I put 8 here, 8 minus 6 is 2, 8 plus 1 is 9, positive into positive gives me positive. Similarly, if I take, say, the number minus 5, minus 5 minus 6, negative minus 11, minus 5 plus 1, minus 4, negative into negative, again positive. So what happens? If you're solving it theoretically, then remember, you have to break it into two cases. Okay, we break this into two cases. Right. Now, as I said, that, see, the theoretical method is slightly lengthier. Instead, let's learn a different method which is much faster. Okay, and this again comes from theory. It comes from the graph of quadratic equation. So this method always works. Okay, so the question was x square minus 5x minus 6 greater than 0. We solved it. We got the roots as 6 and minus 1. Now, I'll quickly tell you the theory behind it, and then you can just memorize the trick. The point is, see, quadratic equation is written as ax square plus bx plus c. Now, graph of the quadratic equation is always a parabola. Okay, graph of quadratic equation is always a parabola. If a is positive, the parabola looks like this. Okay, if a is positive, the parabola looks like this, and when a is negative, the parabola looks downwards. The point being, see, these points where it crosses your x-axis, these are your roots. Okay, these are your roots. So if I basically try to draw a diagram for this, okay, a graph for this, minus 1 comes here, 6 comes here, my parabola looks like this. Okay, this is how the graph for this function will look. Now if you see, if I draw my, say, y-axis also, which will be, say, here, if I draw a y-axis also, you know y is positive here and y is negative here. Okay, above the x-axis y is positive, below the y-axis, below the x-axis y is negative, right? So what does that tell you? That in this region the answer is positive because it's above the x-axis. In this region the answer is negative because it is below the x-axis, and similarly in this region the answer is positive because again it is above the x-axis. Alright, if I want to summarize, you can draw the graph. So you solve the quadratic equation, draw the roots, place the roots, then what do? Just draw the graph. If a is positive, okay, the term with x square, if that is positive, the graph will be upwards, the answer will be plus minus plus. Okay, the graph will go upwards, the parabola goes upwards. If a is negative, the same parabola goes downwards. Then you look where the region is above the x-axis is positive, below the x-axis is negative, so you know your regions. Now how do we answer then? See, what does the question want from us? It wants greater than 0. So it wants the overall answer to be positive. So where is the overall answer positive? In this region and in this region. Now if you know the way number line works is, if you go from left to right, the values increase. So if x is ahead of 6, that means x is greater than 6. If x is behind -1, that means x is less than -1. So we get two answers here, x less than -1 or x greater than 6. Okay, so this is your graphical method, okay, to solve the same. So if you understand the graphical method, that is what your trick is based on. Okay, what we do, we have x square minus 5x minus 6 greater than 0. Quickly find the roots. X is -1 and 6. Draw your diagram, plot -1, plot 6. Now if you're not interested in drawing the graph and all, no problem. Simply write plus minus plus. Always start from the right corner. Okay, always start from the right corner and always give the sign plus. Alright, and one more point then, make sure that the coefficient of x is also positive. Okay, just write plus minus plus. And now what is the question wanting? It wants x answer to be greater than 0. So directly place x and you get the answer. Okay, let's look at a different question and apply the same thing. Say we have minus x square, say minus x square minus 5x minus 6 greater than 0. Okay, minus x square minus 5x minus 6 greater than 0. First thing I do, I don't want this negative sign. So I multiply everything by -1. I get x square plus 5x plus 6 less than 0. Remember, whenever I multiply or divide by a negative sign, the inequality sign changes. Now if you do the roots are -2 and -3. If you find the roots are -2 and -3. Again number line -3, -2, plus minus plus. What do I want? The question wants less than 0. Less than 0 means negative region. Less than 0 means negative region. So x is between -3 and -2. So x is between -3 and -2. Okay, I hope you understand this. Let me give you simple pointers to remember. Okay, whenever you are solving quadratic or higher order inequality, okay, what are the steps you can follow to solve question quickly? Step number 1, the coefficient of highest power of x, okay, has to be positive. Okay, one thing you always do is you make sure the coefficient of highest power of x is positive. Okay, then solve and find the roots. Okay, you solve, You solve the equation, whatever it is, whatever the algebraic expression is, solve it, find the roots. Okay, you plot the roots on the number line. Okay, you plot all your roots on number line. Okay, and then this is important, right? Start from right corner. Okay, let me write this in a different way. So, okay, starting from right corner, this is important. Okay, start naming the regions positive or negative, alternative. Okay, what do? You start from the right corner and start giving your regions positive and negative sign alternatively, right? Final step. Okay, pick the region based on the question. Okay, once you have named all your regions positive and negative, then you go back to the question and see, okay, what is it they want? They want greater than 0, pick all your positive regions. They want less than 0, pick all your negative regions. Okay, let's see this in another example. Say I have x plus 5, x minus 2 by x minus 3, or x plus 5, x minus 2, x minus 3, 1 minus x greater than 0. Okay, now if you look, this is your normal equation, right? It was quadratic on top, quadratic on bottom. I've already simplified it for you. Now before we go and find roots, what is the first condition? The coefficient of x should always be positive. The highest term of x should always be positive. It is positive here, positive here, positive here, not positive here. So what do? I multiply this, or I take minus sign out and send it to the other side. So I have x plus 5, x minus 2, x minus 3, x minus 1 less than 0. Okay, what did I do? This minus sign I took common, and this minus sign I shifted to the other side. Now whenever you multiply by a minus number, the inequality sign changes. Now that we have everything in factor form, directly draw the number line, mark the roots. Okay, the roots are minus 5, 1, 2 and 3. Start from the right corner, plus, minus, plus, minus, plus. Okay, start from the right corner, plus, minus, plus, minus, plus. Alternate, you have to give the signs. Now, what do we want? What does the question want? Less than 0. Less than 0 means x lies in the negative region. Okay, x lies in the negative region. Okay, so this is how you can solve higher order inequalities as well. Quadratic, higher or cubic, biquadratic, okay, any sort of inequalities. This is how you can solve them easily. I hope you have read the question. We have minus 20 less than 7k minus 5 less than equal to 4. Okay, now remember, read the question carefully. See, it says integer values. Okay, so we don't want all values of k, we want only the integer values of k. Okay, multiple inequalities. Let me add 5 on each sides. Right, say 7k, 4 plus 5. Divide by 7 on each side, minus 15 by 7, K 9/7. Okay, this is minus 2.14. Okay, this is 1.2 roughly. Okay, may not be exact, say roughly. Now again, remember, what do we want? We want integer values of k. So k is between minus 2 and 1. K is an integer between minus 2 and 1. So how many values are there? 4. Okay, 4. Do not forget 0. Alright, moving on to the next one. You see, this is a slightly different question. We know PQR is negative, we know QRS is positive, and we want to know which one is definitely negative. Okay, so if I just write it down here, P times Q times R is negative, Q times R times S is positive. Okay, that is all I know. I don't know the individual signs of PQR or S, but I just know that product of PQR is negative, product of QRS is positive. Alright, now if you observe one thing, both the terms have Q and R in it. Okay, both the terms have Q and R in it. Okay, now what is happening? See, when Q and R, okay, when this Q and R, okay, when this Q and R is getting multiplied by P, it is becoming negative. And similarly, when this Q and R is getting multiplied by S, it is becoming positive. Now, I don't know whether QR is positive or negative, but it will have the same sign in both the places. Okay, QR can be positive or QR can be negative. Okay, but if it is positive, then I know P is negative. If it is positive, I know S is positive. Similarly, if QR is negative, P is positive, QR is negative, S is negative. The point being, the same number or the same term when multiplied to P and S gives me different sign. Why? This tells us that P and S have to be of opposite signs. Okay, one of them has to be positive and the other has to be negative. Because see, when P and S are multiplied to the same term Q and R, why is the answer of different signs? That means P and S are of opposite signs. Okay, Q and R, I don't know. QR could be positive, negative, I do not know. The only thing my takeaway from this is P and S are of opposite signs. Okay, so now with this idea or with this knowledge, let's jump to questions. If you look at option A, it is P square. P square I know is positive. Okay, P square I know is positive. But what about QRS? I don't know anything. Okay, so I can't say what will be option A. Similarly, if you look at B option, all the powers are even. All the powers are even means this is definitely positive. But the question wants a definite negative, so cannot be option B. If I look at option C, Q power 4, so I know this is positive. P and S are of opposite sign, so I know P into S is negative. Okay, but R remains. So I know P into S is negative, that's done. Q power 4, so Q does not matter. But now R remains. I don't know the sign of R. So again, I can't say whether it is definitely positive or negative. If you look at option D, it is QR to the power 4. Again, power 4 means even power means definitely positive. So QR is gone. P into S, I know from here, P into S is negative. So this will be definitely negative. Okay, this will be definitely negative. Why? Because QR is power 4, which is positive. PS is negative. Positive into negative is definitely negative. Okay, so I hope you understand this. See, the point I am trying to make here is, instead of plugging in values, okay, instead of plugging in values, try and understand how to solve all these questions quickly and theoretically. Okay, the advantage of that is, when you do so, your confidence is high. You know that yes, this is definitely the answer. Whereas when you are plugging in values, you are never sure whether I have, whether you have put all the possible values or not, or the values you have put, have you missed out on something which negates this? Okay, you're always underconfident, or you always doubt yourself. So instead of plugging in values, please try and understand how we can solve all of this very easily, quickly, and theoretically, and so that we can be more confident while we are answering the question. Alright, again another question. Again, try not to plug in. Let's try to solve this theoretically. So we know m and n are integers, and m is less than 0 and n is greater than 0. That means m is negative, n is positive. Okay, at the same time, we know t is a non-negative integer. Non-negative integer means it's either 0 or positive. It is either 0 or positive. Okay, now the question comes, which of the following must be true? Okay, alright. Now if you look at step number 1, we have option number 1, we have m square less than n square. Again, I know m is negative, I know n is positive. I know square of both of these is going to be positive. But again, which one will be greater? I don't know that. So cannot be my answer. Similarly, m plus n is 0. I don't know whether they are of equal value or not. So again, cannot be my answer. We have Tm less than Tn. Okay, interesting. See, we know m is less than n. Okay, because m is negative, n is positive. But t is greater than equal to 0. So when I multiply t on both sides, because it is greater than, t is a positive term. If t is a positive term, sign does not change. If it is equal to, it remains equal to. So when I multiply t on both sides, I get Tm is less than equal to Tn. Because if t is 0, then they need to be equal to each other. So almost there, but again not our answer. Tm not equal to Tn, we just covered this. Tm can be equal to Tn, which means fifth option has to be our answer. That is m by n is less than t. Right? Again, let's see how this works. So we know m is less than n. Okay. So if I say cross multiply, I know m by n, right, is negative. Okay, because m is negative, n is positive. So m by n is negative, right? M is negative, n is positive, and I know t is greater than equal to 0. Okay, I know t is greater than equal to 0, right? Which means m by n will always be less than t, which means m by n will always be less than t. Alright, moving on to the next question. We have y cube less than 25y. Now, you might be tempted to cross multiply the y. Okay, you might be tempted to cross multiply the y, but remember, don't do that. We cannot cross multiply variables unless we know the sign of those variables. And from the question, I don't know what y is. Okay, from the question, I don't know what y is. So, do not cross multiply the y and y cube. Okay, instead, get everything on same side. Okay, we can take y common, y square minus 25. We can apply a square minus b square. We'll solve it using higher order inequalities. These are my 3 roots. Okay, we write plus minus plus minus. What do we want? Less than 0. That means y is either less than minus 5 or y is between 0 to 5. Okay, y is either less than minus 5 or y is between 0 to 5. Okay, now If you read the question says which of the following options cannot be true. Okay. Now if you look at modulus y greater than 5, it can be true, because if y is less than minus 5, say minus 6, then modulus y can be greater than 5. So this can be true. Y greater than minus 5, yes, if y is between 0 to 5, y, right, can be true. Y less than minus 5, this is definitely true, right, this is definitely true. Y greater than 5, now if you look, both your options are less than 5. Y greater than 5 is not possible, so this cannot be true, right, this cannot be true, hence our answer becomes y greater than 5. Okay, now quick point, again remember, cannot cancel y and y cube. This is slightly similar to the previous one. We have z cube less than z square. Okay, what I can do, I can simply cancel z square with z cube. I get z power 1 less than 1. Okay, let that sink in. Don't shout or yell that okay, previous question I said you can't cancel variable, why am I cancelling variable now? So again, observe, the point of not cancelling variable is you do not know the sign of the variable. See, in the previous question, y cube less than 25y, I did not know what y was. Okay, but if you look at this question, okay, if you look at this question, I know z square is positive. I don't know what z is. Okay, I do not know what z is. Could be positive number, could be negative number. But z square is definitely positive. Okay, z square is definitely positive. So I can confidently cancel z square and keep the same sign. Okay, I can, what do you say, confidently cancel z square and z square on both sides and keep the same sign. Okay, so I get to know that z is less than 1. Alright, if I get 1 on this side, I know z minus 1 is less than 0. Okay, what do they want? Which of the following will definitely be negative? So z minus 1 is definitely negative. Remember, you cannot cross multiply variables if you don't know the sign of the variable. If you know, you can cancel and change the sign or keep the sign accordingly. Okay. Moving to the next question, we know C is less than D is less than 0. That means both C and D are negative values. Again, instead of plugging in, let's try to solve this theoretically. Again, the question is, which of the following must be true? If you square both sides, okay, C is a much smaller number. If you square both sides, we know C square will be greater than D square. So option A is definitely not it. B, D minus 12 is less than C. I know D is greater than C, but if I subtract 12, I don't know what will happen because I'm subtracting 12 only on one side. Third option, D plus C is greater than C. C goes there, D greater than 0. Again, not it. Fourth option, CD is less than D square. Okay, let's look at it. So I know that C is less than D. If I multiply both sides by D, okay, if I multiply both sides by D, I will get, and I know D is a negative number, so I need to change the sign to CD will be greater than D square. Okay, CD will be greater than D square. See, I am multiplying D on both the sides. I can do that, but D is a negative number, so I need to change the sign. So I know D cannot be it, which means E has to be your answer. Again, if you see, C is less than D. If I multiply both sides by C and C is a negative number, so I know C square is greater than CD. Okay, so again, without plugging in, we are trying to solve questions. So if you have read the question, again similar to what we did just now, I know U is negative and I know 5B is greater than U. Okay, so let me cross multiply. I know V is greater than U by 5. Okay, see, we need the value of V by U. Okay, so let's get V by U on the same side. Now when I cross multiply the U, because U is negative, the inequality sign will change. Okay, I can cross multiply U because I know U is negative. I cannot cross multiply V because I don't know what V is, but I know U is negative. So when I cross multiply U, sign changes. I know V by U is less than 1 by 5. So if you look at the options, less than 1 by 5, this is the only one. A higher order inequality, let's write it down, simplify it down. We have x minus 3 whole square, x plus 2 whole power 5, x square minus 16 less than 0. Okay, now I can see this is a square minus b square, so x minus 3 whole square, x plus 2 whole power 5, x plus 4 into x minus 4 less than 0. Okay, now do not rush, don't directly jump into your number line. See, observe this. Okay, this, right, is definitely positive because square of anything or even power is always positive, and since it is positive, I can cross multiply this. Okay, since this is positive, I can cross multiply this to the other side and I will be left with I will be left with x plus 2 whole power 5, x plus 4, x minus 4 less than 0. Okay, similarly, x plus 2 whole power 4 into x plus 2, x plus 4, x minus 4. Okay, what did I do? I just separated the power 5 as power 4 and power 1. The power 4, since it is positive, again goes there. I can simplify my question further to x plus 2, x plus 4, x minus 4 less than 0. Now all of these have power 1. That is okay. Now I don't know the sign. So now I solve this. Minus 4 plus 2 plus 4 plus minus. We want less than 0. So x is between 2 and 4 and x is less than minus 4. Okay, x is between 2 and 4 and less than minus 4. Okay, that should be plus 2. If you've seen this question, this is similar to what we did just now, right? We have x minus 6 whole cube, 3 minus 5x less than 0. Step number 1, what we learned in the previous one, the cube, I can send the square to the other side. I have x minus 6 power 1, 3 minus 5x less than 0. Now remember, don't rush. Coefficient of x is negative. We don't want that. So we take minus sign common and we cross multiply the minus sign. Okay, we cross multiply the minus sign. And now you can do your number line. 3 by 5, 6 plus minus plus. We are looking for positive. So x is greater than 6, x is less than 3 by 5. Right? So the answer becomes less than 3 by 5 and greater than 6. Remember, do not rush. Coefficient of x has to become positive. Alright, moving to the next one. So we know a square is greater than b square. Alright, it's an interesting question. Okay, this takes us to the previous topic. Okay, absolute values. Those of you if you have not watched that, please go and watch that. You learn this concept there. See, the idea is, this is our method number 2. A square is greater than b square. So again, don't just jump and cancel the square and say a is greater than b. Okay, that is wrong. Okay, that is wrong. Why is it wrong? So again, recall the theory that we did last time. Square root of variables is always modulus. So when you are doing square root on both sides, okay, you can do that, but when you are doing square root on both sides, remember, square root of variables is always modulus. Okay, so the answer will be D and not A. Okay, the answer will be option D and not A, because square root of variables is always modulus. Okay. Alright guys, so I hope you were able to understand the concept of inequalities. Again, remember, this is our concept builder video. We do have other topics to be covered, such as addition and subtraction. So if you have simultaneous equation, okay, whenever we do linear equations, we do learn single variable equations, two variable equations. We also learn simultaneous equations. Similarly, okay, in the next part we will learn addition, subtraction of inequalities, how you add inequalities, how do you subtract them. Similarly, how you multiply or divide them. Okay, how to solve simultaneous inequalities, how to solve fraction inequalities. So all these topics we will do next time. Meanwhile, I hope you were able to understand the basic concept of inequalities and able to learn. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.